Hello, today we are doing our last lesson of Chapter 8, 8.3, which is using zero and negative exponents. So we're going to start with the ones that we know. We're going to start from here up. So 9 to the power of 1, that's 9 just one time. 9 to the power of 2, that's 9 two times. 9 times 9 we know is 81. We could also write that as 9 to the power of 2, which is where it was to begin with. 9 to the power of 3 is multiplying 9 three times. So we already have 81 times another 9. We could plug that in our calculator. 81 times 9 gives us 729. And then 9 to the fourth is 9 times 9 times 9 times 9 again. So we just have 729 times another 9 is 6,561. Now, I don't really care about these numbers so much, don't really matter, but what I want you to notice is that each time there's another 9. There's 3 9s and there's 4 9s. So going up the list, if we were going this way, we're multiplying by 9 one more time. So what's the math going down the list then? If we instead look this direction, we're losing a 9 every time. So if we were to divide by 9, like if I have 9 to the third divided by 9, well, 1 eliminates and now I only have 9 to the second. If I divide by 9, I eliminate and I have 9 to the first. So we're really dividing by 9 going the other direction, which makes sense because multiply and divide are opposites of each other, inverses. So if we continue that pattern down into the negatives, we know that if we have 9 and we divide it by 9, well, 9 divided by 9 is 1. That's why anything to the power of 0 is 1, because there's no 9s left over. Now if we continue and divide by 9, we have 1 divided by 9. Well, how do we get from this to this? Well, it's really telling us we have 1 9. The negative just means we need to move it to the other side of our fraction. So it really means we divided by 9 instead of multiplied by 9. So if we have our pattern to continue, if we divide by 9 again, we have 1 over 9 and then another 9 in the bottom, also known as 9 to the power of 2. In the denominator, because it's a negative exponent, means it's really moving to the opposite side of our fraction, like numerator and denominator. This is technically in the numerator 9 to the power of negative 1. So to make our exponent positive, we need to move it to the bottom, because it's really dividing by 9 instead of multiplying. Same thing if we continue, if we divide by 9 again. We've divided by 9 three times. Divide by 9, divide by 9. So that's 1 over 9 to the power of 3. We'll normally leave these in exponent form instead of multiplying them out. And our last thing here, you must leave in fraction form, no decimals. I don't want you to plug this in your calculator. Okay? So let's take a look at a couple here. Simplify the expression, write your answer using only positive exponents. So we have 3 to the negative 2. If it's not a fraction, I'm going to make it a fraction. This negative tells us it's really division, so this term really needs to be moved to the bottom. So we have 3 2 times on the bottom of our fraction. If there's nothing on the top, it's just a 1, because if we multiply our fraction by 1, it doesn't change. And that is our answer. Simply move and make positive. That's what I like to say. Move and make positive. So if we look at this next one, this number here does not matter. If the exponent is negative, we move it to the bottom of the fraction, or the other side of the fraction. This one just happens to be on the top. So if we move it to the bottom, we really have that number, negative 8, 4 times on the bottom. The number is still negative. That doesn't change. It's only the exponent that you're changing. Move and make the exponent positive. And there's a 1 on top if there's nothing left over. That is our answer. Well, this next one, our negative exponents are already on the bottom. So if you divide by another division, the opposite of division would be multiplication. So this negative exponent really is going to be moving to the top. Okay? This is if we really wanted to write it out. We have 1 divided by, and then if I make this a fraction and flip it, oops, if I made that a fraction, 3 to the negative 4th over 1, we could flip this and it would really end up on the top. That's, I think, getting into too much depth. So we're just really going to flip this over and move it and make positive, just like we did over here. So we have 3 to the power of 4 over 1. Move and make positive. We don't really need the divide by 1, so this is really just 3 to the power of 4. All right, if we have a negative exponent, we need to make this a fraction. Just make the entire thing a fraction. This is the only piece we have a negative exponent, so we need to move it and make positive because it's really dividing by 6 4 times. So we have 6 to the 4th, oops, on the top. And then this one moved down to the bottom, move it, and make the exponent a positive. That moved down here. So if we wrote that out, we'd have 6 4 times. And on the bottom, they all eliminate. 6 times 6 times 6 times 6, or 6 divided by 6 is 1, times 1 times 1 times 1 is 1. If you use your subtraction method, 4 minus 4 is 0. You'd have 6 to the power of 0, which is 1. All right, now these next two are very similar. The only difference is our exponents. So we know if we have an exponent, we could write this 2 times. We could write 2 fifths, 2 fifths. And we'd have 2 2s and 2 5s. And you could write it using positive exponents, just like that. Or you could distribute your exponent to each part of the fraction. So the tricky part is, well, how do you write this 2 times if it's a negative exponent? What you have to do if you have a negative exponent with a fraction is 2 things. Either 1, distribute your exponent, and you can write 2 to the negative 2 power and 5 to the negative 2 power. Or you can move the fraction and make the exponent positive. So you can make it 5 over 2 and make the exponent positive. If you do that, you will still get the same answer, because this we're going to have to move to the top, and this we're going to have to move to the bottom. So we're still going to end up with 5 to the power of 2 and 2 to the power of 2. Move and make positive. So that negative really just tells us we're flipping our fraction. All right, same directions here. Right, using only positive exponents. However, we know anything to the power of 0 is 1. So that one's pretty easy. This next one, we have a negative exponent on the bottom. We have to move and make positive. So we have 6 3 times on the top. There's nothing on the bottom. It's a 1. You don't really need to divide by 1. It's just 6 to the power of 3. Next, this whole thing is to the power of negative 4. So we need to move that whole thing to the bottom. So we have 1 over 3x to the power of 4. However, we need to distribute this exponent as well. So we really have 1 over 3 to the 4th and x to the 4th. You could have distributed right away as well and made it 3 to the negative 4 and x to the negative 4, and then moved them both to the bottom. You will still get this answer. All right, we have a negative exponent. We're going to make it a fraction. Be careful though, this is the only part that has a negative exponent. The a to the 3rd is going to stay on the top because it doesn't need to move. It already has a positive exponent. If you move it, it would become negative. So we need to move this to the bottom. So we have our b's on the bottom, and there are 2 of them. Move and make the exponent positive. All right, next one. If you want to distribute right away, we have negative 5 to the power of negative 3 and g to the power of negative 3. Either way, you're moving, and making positive. You could have done that right away as well. If you want to just move the whole thing to the bottom, that works as well. negative 5g to the power of 3, but you still need to distribute or write this out 3 times. You'd have negative 5 3 times and g 3 times. All right, on this next one, the only negative exponent we have is the top. So the 5 to the power of 2 stays on the bottom. There's nothing going to be left on the top because this is also coming to the bottom, so now we have another 5 to the power of 1 on the bottom. So we really have 2 5s and a third 5, so we have 1 over 5 to the power of 3. There's now 3 5s on the bottom. Same thing with this next one, except the opposite. We only need to move these g's because they're the only ones with a negative exponent. So we have g squared, and now we have g to the power of 5. And there's nothing on the bottom, it would just be a 1. But we really have how many g's? 2 and 5 more. We're adding them because this is really 2 g's and then 5 more g's. It's really g to the power of 7. You can put it over 1. If you want to just write g to the power of 7, that's the same as well. Now this next one you need to be careful because this 8 does not have a negative exponent. This is really 1/8. The g and the h both need to be moved because they have negative exponents. So the 8 stays on the bottom, our g's are on the top, move and make the exponent positive, and the h's, move and make the exponent positive. If you want to put the 1 there you can, but you don't need it because multiplying by 1 isn't going to change our answer. And this last one, I do not care anything about what's in the middle. If the whole thing is to the power of 0, your answer is 1. Alright, I know that was a little bit tricky with our negative exponents. If you have questions, please let me know.